Factorizing cubic polynomials. We are only expected to do this in situations where a linear factor is easily found. To find a linear factor, we may use the factor theorem. This is a special case of the remainder theorem. In general, if f of x is a polynomial function of x, which, when divided by the linear function x minus a, gives a quotient q of x and a remainder r, the relationship between the expressions is f of x is equal to x minus a q of x plus r. Now, if that seems confusing, consider the following. If you think about this with numbers, let's suppose we have a number like 9. If we divide that by 2, then if we think about this before we knew about decimals, we could say that that was 4 with a remainder of 1. And 9 is equal to 2 multiplied by 4 add 1. Now, in this case, the 4 is a quotient. The 1 is a remainder. So it's exactly the same idea here. Here's the divisor, which for us was 2, multiplied by the quotient, which over here is 4, and then add on the remainder. So what we're doing here is exactly the same with polynomials as we could do here with numbers. If we substitute x equals a into this, we get a minus a here. A minus a is 0. 0 times anything is 0. So we just get left with r. So we can say that f of a is equal to r. This result is known as the remainder theorem and can be summarized as follows. When f of x is divided by x minus a, the remainder is f of a. This leads us to the factor theorem. If x minus a is a factor, then the remainder is 0. Remember what a factor is. It would go directly in with no remainder. So we can establish that x minus a is a factor if f of a is equal to 0. For example, if g of x is x cubed minus 4x squared plus 8x minus 8, then g of 2 is equal to 0. So x minus 2 is a factor. Now it's possible that we could go ahead and use the factor theorem to find any other factors. But what's a more usual approach is to then separate the cubic into a linear factor, which is the x minus 2, and a quadratic, and then, if it's possible, we can factorize the quadratic into 2 linear factors. Note, if y is ax cubed plus bx squared plus cx plus d, we only need to try factors of the form factor of d divided by factor of a. So here, with a being 1 and d being negative 8, we only needed to try factors of 8 divided by 1. You can ignore the sign. So therefore we only needed to try 1, 2, 4 and 8. In this course it's unlikely that we will need to try non-integer values. So it's only necessary to try factors of d if this is the case. But try to remember this as a more general case, just in case.